Good morning, everyone. Miss Sydney is here from Ida Public Library, kicking off our very first weekly science spotlight. Every Thursday during our summer challenge, we will be talking about a different area of science. I will be hosting a program in the morning called Kids Lab Live, and you can catch Miss Leah in the afternoon doing the Tween STEAM program. This program I'll present this morning is perfect for children preschool age through early elementary. We will be showing some different experiments that are easy for you to try at home to explore and investigate different areas of science. Today we're talking all about physics. Physics is the science that deals with matter or objects or things and how they move. So there's all kinds of scientific rules about motion, the way things move. And more things move than you think. It's not just something sliding across a table, something falling off your bookshelf. Did you know that sound moves through the air to our ears? And light moves to our eyes. And there's all types of scientific rules about motion, and that's what we call physics. So today we have two different experiments to discover different things about two types of motion. Our first experiment is going to be the object freefall. Our second experiment is called balloon static. I'm going to show you all of the materials that you would need at home to recreate these experiments. You're also going to need a notebook. An important part of any type of science or experiment is writing down your prediction or hypothesis, what you think is going to happen when you do the experiment. Then you gather up all of your materials or supplies that you need, and you go through the steps to conduct the experiment. When you're done, get your journal back out and see if your hypothesis or what you predicted was correct. Why or why not? So, in a second, we're going to get started with the object freefall. Are you ready? Let's get started with our first experiment. It's called the object freefall. The idea for this experiment came from someone a very long time ago, a few thousand years ago, named Aristotle. He was a philosopher, a scientist, who made the hypothesis or prediction that if two objects were dropped at the exact same time from the exact same place, whichever object was heavier would hit the ground first, and whichever object was lighter would hit the ground last. Do you agree with that? He thought about that hypothesis because he thought that the object with more mass, that was heavier, would go faster down to the earth. If an object had less mass, it would take longer to hit the earth. So I think it's time to try this experiment for ourselves. I'm going to tilt my camera down so you can see the materials or supplies that I've gathered to test out this experiment. I have 6 different containers. 1, 2, 3, 4, 5, 6. And I filled each one of these containers with something different. Seashells, a whole bunch of coins like pennies and quarters and dimes, buttons, cereal, feathers, and crayons. And as I'm touching each one of these containers, I can tell that they all weigh a different amount. Some are really heavy, some are really light. If you want to recreate this experiment at home and you don't have containers just like this, you can use an empty plastic water bottle. You could use a Tupperware container. Just make sure that the containers you're testing are about the same size. So one isn't a whole lot bigger than another. Now, just by feeling them, I can tell this one's really heavy. This one's really light. I brought a scale so at home you could see the difference in something heavy and light. If a scale tips to one side, it's showing you an object's really heavy. So I'm going to put these coins on this side. Take a look at that. The buttons don't make it move. The buttons and the crayons don't even make it move. This is a very heavy object. But we could test two that feel kind of similar to me. The buttons in my hand and the seashells in my hand feel really similar. So I can use the scale to test out which one's heavier. Do you see what happened? When I put the seashells in, it makes the buttons rise up. That means the seashells are heavier than the buttons. I wonder if the crayons are heavier than the seashells. What happened? This side of the scale went down. Watch again. What does that mean? Which one is heavier, the seashells or the crayons? Yeah, the crayons are heavier. So take a little bit of time when you do this experiment to inspect, investigate, feel how heavy the different objects that you choose are in your hands. And then I want you to line up your cups in order of which ones you think will fall the fastest, all the way to which ones you think would fall the slowest. Does that make sense? So these coins are really heavy. If Aristotle's prediction is correct, that would mean that these would fall the fastest because they're the heaviest. My feathers are really, really, really light. That would mean, by Aristotle's prediction, they would fall the slowest. Go ahead and pause the video now to gather up your supplies and make your hypothesis or prediction. Which ones do you think will fall the fastest? Which ones do you think will fall the slowest? Do you agree with Aristotle? Why or why not? Write it down in your journal, and then we'll get back together on the video and test out our theory. Okay, so we're outside in Miss Sydney's backyard, and we're going to test out our experiment to see which objects fall faster or slower in our object free fall. I brought outside all of our different containers that we inspected, we weighed them, we made our hypothesis or prediction right. I also have way back there the stool I'm going to stand on. If you're going to climb up on a stool or stand on a chair, please make sure you have a grown-up or someone big that can stand near you to make sure that you stay safe. So I'm going to start out with two objects that when I was kind of investigating them, they felt like they weighed the same. The seashells and the crayons. So what I'm going to do is I'm going to go way to the back and stand on the stool. I'm going to hold both the cups at the exact same height. And on the count of 3, I'm going to drop them at the exact same time. Your job is to use your eagle eyes and watch the ground down below to see which one hits the ground first. Seashell cup or crayon cup. Are you ready? Three, two, one. Friends, could you tell which one hit the ground first? To me, it looked like they hit the ground at the exact same time. What do you think? Does that match your hypothesis? Maybe it's because these weighed so similar. So I'm going to do a second round of our experiment, but I'm going to use the thing that felt heaviest. This cup of pennies and quarters and dimes. They felt very heavy. And this cup of feathers, which felt really light and airy. Review your hypothesis one time before I go and do this. Which one do you think will hit the ground first? The heavy coins or the light feathers? I'm going to conduct the experiment or do it the exact same way as before. I'll hold them at the same place and I'll count to 3. You watch the ground to see which one hits first. Ready? 3, 2, 1. Friends, what happened? Yeah, these coins and these feathers hit the ground at the same time, even though these were really heavy and these were really light. That means Aristotle's hypothesis was not correct. And later, a couple hundred years later, a scientist named Galileo made a new hypothesis. He said that because of Earth's gravity, everything will be pulled down at the exact same rate. Have you heard about gravity before? When you see videos of astronauts going up into their space shuttles, you've seen them floating around in the air, right? Can we do that on Earth? No, our feet stay on the ground, or the ball we bounce goes down toward the sidewalk because of gravity. Everything is pulled toward the Earth with Earth's gravity. That's the reason that these coins fall at the same speed as these feathers. The gravity pulls them down at the same rate. Did you know that? Was your hypothesis correct? Make sure you write down the results of your experiment inside your journal. Are you ready for our second experiment? This one's called balloon static. Before, we talked about the force of motion and gravity, or the Earth's pull everything down to the surface. And we found out that no matter how heavy an object is, it still travels down to the Earth at the same rate. Now we're going to talk about a different kind of physics. Did you know that electricity can be a type of physics? Electricity is something that helps you turn the lights on in your house, but we're not going to use that type of electricity today. We're going to use static electricity, and I bet you've experienced static electricity before. Have you ever been at the park and went down the slide, and when you stood up, your hair was all spread out standing on end? Or have you ever touched something and it shocked you and you said, ouch? That was a surprise. That's static electricity. It's two different electrical charges bumping up against each other. And today, we're going to create static electricity using a balloon. So, before we go any further, I want you to blow up a balloon, touch it in your hand, look at it really closely, and in your journal, I want you to write down your hypothesis or your prediction of what you think might happen if you rubbed the balloon against something and then held it over an object on a piece of paper. The objects that we're going to put on our piece of paper today are salt or sugar and Italian seasoning, or any kind of seasoning that you might have in your spice cabinet. What do you think will happen to these objects on our paper if we hold the balloon over the top of it? Go ahead and pause your video to write your prediction down now, and then we'll get started with our experiment. Okay, are you ready? I'm going to tip you down here so you can see my piece of paper. I chose a plain black piece of paper because I hope it's easier for you at home to see my supplies on top. You don't need to have black. It can be any piece of paper that you have lying around. You can also use plate. But I'm going to sprinkle just a little bit of salt on one side and a little bit of Italian seasoning on the other side. And then you're going to need some sort of piece of fabric. You could use your t-shirt, but Miss City grabbed her dish towel that has little hedgehogs on it from the kitchen. And you're going to take your balloon and you're going to rub it against that. Nice and good. If you're rubbing it on your shirt, rub it on your tummy, rub it on your back, rub it on your side. And once you've rubbed it, I want you to hold that side of the balloon over the top of your paper. Don't touch the paper. Just hold it over the top. Get those listening ears on. I want to see if you can hear what's about to happen. Friends, what do you hear? Yeah, the static on the balloon is picking up the objects. I'm going to tilt you back up to show you my balloon. It's covered in salt and seasoning. The balloon and the static electricity we created by rubbing that piece of cloth on it grabbed the salt and the seasoning and picked it right up. It's stuck to our balloon now. Was your hypothesis correct? I'm so happy that you joined me today for Kids Lab Live. I hope you had fun, and we'll be back next Thursday exploring a different area of science. Want to learn more about physics? Miss Leah has put together an amazing weekly Science Spotlight newsletter. You can find it on our Facebook page. It has additional ideas for experiments you can do at home, book recommendations at all different reading levels, as well as more information about physics. We will be back next week. Thanks so much for watching. Remember, Miss Leah will be back this afternoon for the older kids with Tween Steam. See you next time.